ice-free Arctic in summer, or methane release from permafrost in the Arctic seafloor, I went to the top. Professor Peter Wadhams, Professor of Polar Ice at Cambridge for more than 20 years, and currently Professor Emeritus at Cambridge. Hello, Professor. Professor Peter Wadhams, welcome, and very pleased to see you. Some have called for an ice-free Arctic sea in summer as early as next year, 2018, and some could say possibly could happen as early as this Arctic summer 2017. So what's your view on that?
Well, yes, the trend of ice area in summer has been downwards for a long time, ever since we started to be able to detect the area of sea ice with satellites. The area's been going down, and the rate of decline has accelerated. Also, since we've been able to measure thickness from submarines, that the thickness has gone down even faster, so that the stage is kind of set for a collapse, because the decrease in area is you're dealing with ice which is getting thinner and thinner every year. So there'll come a point where it might all collapse from below rather than collapsing from the outside in, and that may be what's happening just these last couple of months, because a decline in thickness and area together leads you to a smaller and smaller area in the summer. And so the normal predictions, including my own, are that the first thing we'll see in the way of an extreme result is that in September, the month of minimum ice area, will get an ice-free period in the Arctic, just like we have more or less in the Antarctic. But what's happened this year has been a bit unexpected, in that we went right down to a low area in summer. That's as predicted. It wasn't the lowest ever, but it was very nearly the lowest ever. But then the ice has recovered. We're now into December, and the area that it should have grown to, it's far below that. The anomaly in area for November and December is far greater than any of the anomalies in any other months, including the summer months. So something's happened to the Arctic. It's not winter hasn't happened to it yet. It's not growing back. So if it doesn't grow back properly this winter, and leaves us with a much lower area by the end of the growth season in April and May, then the retreat in summer will give us a completely ice-free Arctic next year.
I like your point, because it's not just the extent, where a lot of the charts look at the extent, but a lot of your work has been looking at the thickness of ice. And effectively, we've got an exponential trend, haven't we, rather than a linear trend. So it's like your analogy in your book, Farewell to Ice, where you've used the glass tumbler, and the ice is keeping it cool until the last of the ice melts. But also you can look at the surface and it looks quite a lot of ice in the glass, but actually the volume of the ice cubes is quite thin. And I think that's where we are. So it does seem that we're only 1 or 2 years at the most away from an ice-free Arctic in summer.
Yes, that's a good analogy you make there, that you can have a steady decline because of warming in some parameter, and it's not just Arctic ice, but a lot of other things in the world, that warming will cause things to decline, but it's a decline that goes on until some end is achieved. And the trouble is with ice is that the end is achieved much more quickly because of the combination of area and thickness change, and then the result of that is a complete change in everything. It's essentially a kind of tipping point. In summer, so long as there's any ice there at all, which there always was, then that keeps the water temperature down to zero, because if the solar radiation tries to warm the water just melts more ice. So it is a perfect air conditioning system. The water is kept at zero, the air above it is kept at zero, by the fact that the air is blowing over a 0-degree surface. As soon as that ice goes, however thin it is, if it's there, it has this effect. If it goes, suddenly we're not in the Arctic anymore. We're in a normal ocean, which means the water can warm up. That means it's melting the seabed and allowing methane to be released. And the warmer water then causes increased melt of the remaining ice, because you're putting heat into the ice from the water, which wasn't there before. So just the loss of the ice gives you that sudden boost to warming.
Yes, and I think, so the next point, I think, is that once the summer ice is gone, it's not going to come back easily at all, is it?
No, when it goes, there'll be a big jump in terms of the amount of heat in the Arctic Ocean because of all that extra absorption of radiation in summer, and it just won't come back. It will certainly stay. You'll get some freezing in the subsequent winter, but it won't be nearly as much, and so it'll become ice-free again the following summer, and then the ice-free period will grow, and the number of months that it's ice-free will increase to 2, 3, 4, 5 months perhaps.
So there is definitely a fairly dire trend happening there. And you did touch on methane, which is in the permafrost on the base of the sea in the Arctic Sea, particularly on the shallow areas of the Siberian shelf there. Do you think it's a high probability then that once there is an ice-free summer at least, that within the next few years we could get a significant release of methane?
Yes, I think that could happen very soon, in fact, because already the shallow shelves around the Arctic, the very wide shelves north of Siberia, are already ice-free in summer. So this air conditioning effect is already happening, or the lack of it. So we're already getting warming of the water in the coastal seas around the Arctic, even though it doesn't extend into the central Arctic Ocean. And those coastal seas are covering these very large methane deposits in the sediments, which are only held down by the fact that the permafrost left over from the last ice age extends offshore. But that permafrost is now melting because of the heat being received from the ice-free water. That's an entirely new effect, because it's only started to happen since we had open water in the Arctic summer, which is only the last decade or so. And each year there's a Russian group which goes out and looks for methane plumes and finds more and more every summer. They just came back from a voyage this October and found more than ever before. Each time they go, there's more and more methane being released. So that at the moment is it's having some climatic effect. But if you had a sudden cooperative pulse of methane coming out from the complete melt of this offshore permafrost, that would have a big climatic effect, and very rapidly as well.
Methane is much more potent in the short term, isn't it, than carbon dioxide?
Yes.
And it is a significant amount that could be released.
Yes, it's over 20 times as powerful per molecule, and it has an immediate effect because it has its climatic effect, but then after it's been in the atmosphere for about a decade, it oxidizes to carbon dioxide. So the methane pulse gives you a really huge boost to warming, acting for a short period, and that is just what we don't need at the moment on the Earth. But then if the methane pulse then stops, you'll just go back to the previous trend in warming. Everything is exponential, and this is the frightening thing. I think James Hansen, who's very highly respected scientist, said, well, one of the things we have to really fear in climate change is that it's all exponential because of feedbacks. Everything's accelerating, and that means that you can see things changing very slowly and you don't do anything about them because you think they're going to keep happening slowly. Then suddenly they start happening fast, and you're left with not doing anything about them and having to suffer the consequences.
Thank you so much, Professor Peter Wadhams. and we look forward to catching up soon. As a species, we clearly need to take urgent, massive, coordinated action to prevent the demise of our species. As a species, we have made 5 major blunders, mainly through self-interest and greed. The first is exponential population growth. This is the root cause of all our problems. Even a school child can see that this is a problem about to manifest. It took us 10,000 years to get to 1 billion people, only 120 years to get to 2 billion, and within 100 years we have not only doubled again, but quadrupled. Think about this for a moment. Our second major blunder was not controlling carbon emissions. As population growth has become exponential, so have carbon emissions. 3. Unchecked carbon emissions have led to continued global warming. 4. Unchecked global warming has now reached a critical level of melting the Arctic ice. This is the global air conditioner. It is not made of metal nor plastic, it is made of ice, which is melting away never to return. 5. The ice melt has accelerated self-reinforcing exponential feedback loops of further rapid global change, causing loss of albedo effect, release of potent methane. What are we going to do about it? Politicians will do nothing until there are riots in the street about it. It would be political suicide for them because we are the problem. Millennials, what are you going to do about it? It is your future that has been robbed.